Welcome back friends, welcome in another video tutorial. So today we will going to discuss about the application of colorimeter. This will going to be a very short video, so let's discuss. So first application is very common to us, we have discussed it multiple times, that is it have the ability to derive the concentration of the colored compound by determining the absorbance or the optical density. Okay, the second one is it have the ability to determine the course of the reaction, okay, by determining the rate of formation or disappearance of the light absorbing compound in the range of the visible spectrum of the light. Okay, you can observe this just like with the help of this example, that suppose a reaction is going on where by reaction between A and B, C and D is formed. Okay, so now when we will extremely sorry, when we will pass visible light of appropriate wavelength, okay, that let's say specific for A, so then if reaction is going on, after some time we will find out that absorption is getting lowered, right? Why? Because A is being used up and that is why C is formed, right? And then we will pass a light ray specific for the B, we will observe the similar thing because B is also used up, A and B together reacting with each other to form C and D, right? Similarly, if we pass a light rays of specific wavelength which is specific for C, then we can find out the increase in the absorbance because the concentration of the C will increase. Similarly in case of D, and that is how with the help of this colorimeter we can find out the course of the reaction, okay, by measuring the rate of the formation and disappearance of the light absorbing compound in the range of the visible spectrum of light. Okay, and by colorimeter another important thing that I want to mention, that you can identify a compound, okay, by determining the absorption spectrum in the visible range of the light spectrum. Okay, so let's talk about the example of paracetamol. So paracetamol have a absorbance at 640 nanometer. Okay, so under such circumstances, if paracetamol, if you are suspecting that your compound may be paracetamol, okay, so you can derive the absorption spectrum at the visible range of the light spectrum, right? Because we know that the visible range is up to 400 to 700 nanometer. So if we find out absorbance at 640 nanometer in the absorption spectrum of our compound, then we can conclude that the compound may be paracetamol. Okay, so this is the application part of the colorimeter. Okay, one is to determine the concentration of the colored compound, second is to determine the course of the reaction, right, by determining the rate of formation and disappearance of the light absorbing compound, okay, by using light of visible range, and another important thing, that with the help of colorimeter we can find out the we can find out whether a compound is present or not. Okay, that is the identification of a compound. So that's it for today. So that is all about the application of the colorimeter. Okay, so if we recapitulate them, so the concentration of the colored compound determination, the course of the reaction determination by measuring the rate of formation and rate of disappearance of light absorbing compound in the range of the visible spectrum of the light, and by finding out or by identifying a compound by determining the absorption spectrum in the visible range of the light spectrum. Okay, so that's it for today. We will meet up again in the next video where we will going to talk about the advantage and disadvantages of colorimeter.